In this video, we are going to talk about chain rule method of differentiation. Now, we already have some examples on the screen, but before we proceed to solve any question, there's an important thing you need to know before solving any chain rule example. And the idea is something called function of a function. Function of a function just simply means that when you have a function imputed into another function. So for example, a typical sine function is sine x. Okay, so instead of just writing sine x and I decide to plug in, let's say 5x here, my new function will become sine 5x. So this 5x was substituted for the value of x here. So sine 5x here is a function of a function. Okay, if the same thing happens, say I have x to the power of 6. So instead of just using x here and I decide to substitute something like 6x plus 5, I plug it for the value of x here, my new function becomes 6x plus 5, open bracket, close bracket to the power of 6. So I've replaced the value of x with 6x plus 5. There's a function inside the bracket which is 6x plus 5, and there's a function outside which is to the power of 6. So this is a function of a function. The typical exponential function is e to the power of x. So instead of writing x here, say I have something like sine x used to replace x here. The new function becomes e to the power of sine x. So now this is a function of a function where e doesn't just depend on x, but it depends on another function, which is sine x. So here, x doesn't just depend on to the power of 6, it depends on another function of 6x plus 5. The same thing here. So the idea here is that when a function depends on another function, you have a function of a function. So it is important to understand this so that you know when to apply the chain rule and when not to apply the chain rule. So let's jump into the example. Before I solve anything, I'll write out solution. Now for the first example, we are told to differentiate y is equal to sine of 2x plus 5. So the first thing you want to look for is to look for the function inside the function. The function inside the function here is 2x plus 5. So that means we have to replace u with another letter. So I would say, let's say u is equal to 2x plus 5. Then my function of y become equal to sine u. Now keep in mind that what we are looking for is dy dx. Now the chain rule simply states that if you have a function of a function, dy over dx will be equal to dy over du. If this is what you are using to replace the function inside the function, times du divided by dx. So you notice that it makes sense, like we cancel out this, you still get dy dx in the end. So this is the chain rule. You might want to write it somewhere. So all I need to do now is to look for dy du and du dx and substitute it to get my dy dx. So the thing I look for first is du dx. So if I do du dx here, if I differentiate 2x is differentiated as 2. If I differentiate plus 5 goes to 0. Then here, if I do dy du, this is equal to cos u. So chain rule simply tells us that dy dx is equal to the multiplication of dy du, which is cos u here, times du dx, which is 2. And then this is equal to 2 cos u. So I'll go back to get my value of u. My value of u is 2x plus 5. This is equal to 2 cos 2x plus 5. So this is my final answer, and the dy dx for y is equal to sine 2x plus 5. Let's move on to the next question. The next question says we should differentiate y is equal to, open brackets, 4x plus 6 and then to the power of 6. So you can pause the video and try to solve this one yourself. Like I said in the beginning, you want to identify the function that is inside the function. So here, the function we are looking at here is 4x plus 6. Replace it with another letter. Let's say u here. U is equal to 4x plus 6. If we use u as 4x plus 6, this will tell us that y is equal to u to the power of 6. Since we know that we're going to need du dx and dy du, we can as well differentiate them from here. So du dx here is equal to, if you differentiate 4x, it becomes 4. If you differentiate 6, it becomes 0. Here, we do dy du. Dy du is equal to 6u to the power of 5. So that from here, you have dy dx as equal to, and dy dx is equal to, based on the chain rule, dy over du times du over dx. So the chain rule, this is the chain rule. Then we can now say dy dx is equal to dy du, which is 6u to the power of 5 times 4. And then this is equal to 6 times 4 is 24u to the power of 5. So at this point, what I need to do is to plug in my value of u back. So this is equal to 24, open brackets. The value of u is 4x plus 6, and then to the power of 5. So dy dx here is 24, open brackets, 4x plus 6 to the power of 5. So that's it for this question. Now let's jump into the next question. You can also pause the video and try to solve that one yourself. The third question tells us to differentiate y is equal to cos 2x. So like we do normally, we try to look for the function inside the function. The function inside the function here is 2x. So we say u is equal to 2x. That means that we write y now as equal to cos u. Since we know that in our chain we will need du dx and dy du, we can as well find them from here. So from here, if we differentiate du dx, the answer is equal to 2. If we differentiate cos u, dy du is equal to minus sin u. From here, based on our chain rule, so we say from chain rule, we know that dy dx is equal to dy over du times du over dx. So that from here, we just simply substitute our values and we say dy over dx is equal to, dy du here is minus sin u, so we say minus sin u times du dx. Du dx is 2, so this is 2. This is then equal to 2 times minus sin u is minus 2 sin u. What we simply do from here, like we've been doing before, is to substitute our value of u. So this is minus sin. The value of u is 2x. This is 2x. So that dy dx is equal to this. Now let's move on to the next example. Next example says we should differentiate y is equal to exponential 3 minus x. First thing we do, like we've been doing before, is to look for the function inside the function. And the function inside the function here is 3 minus x. So we write it as, let's give it another letter this time. Let's say this is w is equal to 3 minus x. So that our new value of y becomes y is equal to exponential w. Now at this point, we need the w, the x, and the y, the w for our chain rule, of course. So that the w dx is equal to, if you differentiate 3 here, it becomes 0. Differentiate minus x here, it becomes minus 1. And then if you're differentiating an exponential function of e to the power of w, the y, the w is still equal to e to the power of w. From your chain rule, using chain rule, dy dx is equal to dy. Now note that what we replaced our function is w. So dy dw times dw dx. So that from here we have dy dx is equal to dy dw is e to the power of w. So write e to the power of w times dw dx is minus 1. So we write minus 1 here. Now from here, this is equal to minus 1 times e to the power of w is minus e to the power of w. So that we can write this as, if you plug in the value of w back into this equation, it becomes minus exponential 3 minus x. So dy dx here is this. So let's take the last example. Now for the last example, you can pause the video and also try to solve it yourself. Now the last example simply says y is equal to ln of 3 minus 4 cosine x. Now what you want to do is find the function inside the function. The function inside the function here is 3 minus 4 cos x. So let's write this as h. This will be h is equal to 3 minus 4 cos x. Now at this point, my value of y simply becomes y is equal to ln h. So that if I'm doing the h dx here, because I know I need the h dx and the y dh, if I'm doing dh over dx, this is equal to, now if I'm differentiating 3, it becomes 0, so this is 0. If I'm differentiating this is a constant times a factor. So if I'm differentiating this, it becomes minus 4 times open bracket minus sine x. Minus multiplied by the minus here is equal to 4 sine x. And then for this one, dy dh is simply equal to 1 over h times dh. Now if I'm differentiating h by itself, it becomes 1. So this is simply equal to 1 over h. Now at this point, you can use your chain rule. So using chain rule, you have dy dx is equal to dy over dh times dh over dx. If you use dy dh from here, dy dh is 1 over h times dh dx is 4 sine x. So this is simply equal to, denominator is saying 1 times 4 sine x. So this is 4 sine x divided by, for the numerator, we have 1 times 4 sine x. So we have 4 sine x for the new numerator divided by the value of h that we got from taking the function of the function is 3 minus 4 cos x. Write it down. This is 3 minus 4 cos x. That means the y dx is equal to this. So that's it. That's how to solve problems on that chain rule. If you liked the video, leave a thumbs up, share with your friends, and subscribe to the channel. Thank you for watching.